For our next speaker, before the break, we have Stefan Lüders from CERN. Regular attendees of Swiss Cyberstorm will remember Stefan Lüders. He's not only the guy winning all the cool Lego sets from the raffle, he's also one of the best speakers we've had before, and that's why we invited him back again with his own version of cloud and data warehouse nightmares. Wonderful. Please welcome Stefan.
Thank you very much. Pleasure being here. Unfortunately, I will not come with solutions. I will come only with problems, and I'm looking for advice because I'm a too old fart in this role. I'm doing this for 20 years, and life was very easy 10 years ago, but nowadays, I'm literally having data center nightmares. So talking about computer centers, I'm basing computer security on two mantras: defense and depth, and there we're talking about agile and timely patching, vulnerability management, secure and professional software development life cycles, software bill of materials, yara, yara, yara. So that is defense and depth. And the second mantra I'm basing on is KISS, keep it simple, stupid. And this is how we did computer center in the past. And I will not talk about defense and depth. I will just talk about computer centers. And this is how one computer center at CERN looked like a couple of years ago. Lots of toasters. The toasters were easy because they were running in hardware with some rudimentary BIOS, which you cannot even alter. And if you want to alter it, you have to go there and you flash the RAM. We had an operating system, and we had the application on top of that. Beautiful, because that was the computer stack, the data center stack we were running for our accelerators, for example. That's a picture of an accelerator. We got lots and lots of control systems there, underground installations, control centers, and in control centers, we were running a little computer center with lots and lots of those toasters, which are then running all the industrial applications. Brilliant. For data analysis, the experiments were taking the data with their own cameras. Here you can see a picture of one of those collisions, and all this data was stored onto PC farms and toasters. Very convenient, apart from the control system, so I got this well separated. We're doing number crunching. All the data is then going into a computing grid. And even there, what we had is PC farms and toasters. Thousands of them, but they were in their own computer center. And everybody working at CERN on the CERN side had the PC under the desk. That was brilliant. That was the past. And that did not give me any nightmares. Thank you very much. However, there's a stupid third mantra of computer security, and that starts with keep it simple, stupid. It is not simple anymore. We're building up computer centers which are becoming complex. The whole IT infrastructure we're running nowadays, it's a completely fuck-up. I'm sorry for the word. It makes me a secure nightmare. And the third mantra is convenient, cheap, secure, pick two. This is why we're all losing, because nobody loves security, because we're not bringing any immediate benefit to the organization. Only when the shit is hitting the fan. This is then when the people come to us and saying, look here, yeah, we got a problem. So looking at my computer center, oh, that was lovely. But my computer center is now looking like this one. Pizza box PCs. I still got hardware, but the hardware nowadays is running a full-blown operating system. And if there's a new CVE coming out, I have to patch it. Have you ever communicated with all the Supermicros, Dells, HPs, and so on to get the new firmware for your hardware, for your BIOS, for your APMI, for your BMC? That takes months until you get the new firmware, if you get it at all. So first complication there. Then we get a hypervisor. Oh, that is new now. Hypervisors, because we run everything in virtual machines, which is brilliant because now we can take benefit of all the single CPU cores in the hardware. So we got VMs, virtual machines, and we got the application inside. We got more VMs, containers, and we put applications in the containers. And more containers, and more applications, and even more applications. So my computer center easiness from my pizza box, from my toasters, of 3 layers, went now to 5 layers. Now everything, of course, is agile and elastic. This is why we're doing it. We're having now a big computer center, and now we can shift the things, containers back and forth. So if one hardware is going down, we can put it to another hardware. If I need to spawn up some more virtual machines for remote desktop because there's another pandemic coming, it's easily done. You want to do machine learning, you need to have certain resources. You spawn up your virtual machines, your containers, and there it is, agile and elastic. We can have means for business continuity and disaster recovery, redundancy and mirroring the things, load balancers, big data, machine learning, ChatGPT in the future. All those things are coming, but you need to have a big data center, and my toasters from the past can't do it anymore. And then we're talking about hybrid clouds, public clouds, private clouds. Cloud computing is also in there, and this is more or less this typical stack for cloud computing. And then don't talk about GPUs and quantum computing, because we are now doing machine learning and we're not using CPUs anymore, now it's GPUs, and you cannot have lots of GPUs in individual spots. You would like to benefit from elasticity and having them in a central place. So here we are again. The control system experts would like now to use machine learning for predictive maintenance, knowing when their PLCs, when their hardware is failing. The analysts of experiments would like to use machine learning, big data models, to analyze the data better than in the past. And also the data amount has increased. When we had in the past something like terabytes, we just hit in September the 1 exabyte limit of storage in our computer center. So how do you do this one? You cannot just have 3, 4, 5 different computer centers. And then our users, they would like to use computing center resources. They would like to spawn up virtual machines for the web page with their CV on for the experiment. They would like to do some tests. They would like to program maybe in another language. They would like to spawn up a Linux machine because their office machine is just a PC. So all of them are now using one computer center. And this is where my nightmares are starting. So let's cable up my computer center. I have a management network for the hardware. So I can control the hardware easily. I can go for the BIOSes. I can go for the IPMI. And I got a second network for provisioning, because somewhere I have to pump in the virtual machine, the containers, so they're starting running. But of course, I separate those ones, ideally, from the internet, because this is then where my customer is sitting. Or the physicists who want to go on certain web pages, making conference system, going on a car booking page, or going on the database on demand, downloading some software, whatever else they want to do. And we're running something like 60,000 virtual machines in our computer center on this hardware. The computer center, the biggest one, has something like 12,000 enclosures. Elasticity. You're arranging for a very big conference, you just spawn up more virtual machines, which are then taking care of all your clients and all your guests. The industrial controls people would like to use the same infrastructure. Nowadays, control systems are not anymore the step 7 things which you program locally. Nowadays, programming for control systems is done like you do a programming for a web page. You're using Git, GitLab, some the pipelines for building the code, and then you push the code down. You get common repositories, you're using standard databases, and all the databases are stored in the same computer center, in the same data center stack. So now here comes my first problem. Virtualization of my network? Or do I spend money and have a 4-fold network separation? Of course, if I separate my network 4-fold with all the switches and routers, it's more costly and violating the third mantra, but it's more secure because if my hardware is failing, at least it is not bridging the networks. Nobody is doing this. Virtual LANs are there and SDNs are there, software-defined networks. And even doesn't matter, because I need to manage my network anyhow, somehow. You need to have DHCP, you need to have NTP, you need to have domain name servers, and so on. So do I want to quadruplicate those infrastructure, or do I want to have only one set? If I quadruple it, I need to have some master replicas, synchronization between them, because this is how the DNS is working. If I keep them all together, then I don't need to separate my networks anyhow, because I got already bridging of my networks. But let's ignore this. We have seen this in the past, the fuck up which happened with SolarWinds. But not talking about this one, we're already doomed anyhow, because if I look closer, my hypervisors are already bridging virtual machines if they have vulnerabilities inside. So now I have the option. Do I create a computer center with hypervisors only for a dedicated purpose, accelerators, and a second one for experiments, and the third one for users? Or do I put everything together? I would like to have 4, or 3 in this case. My data center managers want to have 1, because they're talking about elasticity. If the physicists are all not there in the night, we can use the resources for number crunching. If there's nothing to number crunch, we can use it for simulation of the accelerators. So put everything in one computer center. I'm losing once more mantra number 3 is kicking in. And the same you can have with containerization. Bullshit not happening? Yes, it is. Intel, AMD, again and again and again. I'm happy that there was nothing really in the wild which was really exploitable. But I still have to patch a computer center. When Spectre Meltdown came in, it took us 48 hours, and we put 70,000 servers into sleep and then ramped them up again just to have this fixed. Congratulations. And we did it 2019 again, 2022, but now we have routine and those things. So common bare metal. So do I need to separate my networks if my hypervisor is already bridging the network, potentially if there are vulnerabilities? Let's think. And then I get my users. I have an e-logbook, a logbook. In the past it was written. Nowadays it's a web page. So the Accelerator people writing in this logbook of all the events. Power cut here, power supply failure here, cryogenics, high temperature, whatever else, in the logbook. But it's not sufficient that it's visible to them when they run the Accelerator. They would like to see it in the offices. So I have one application which is visible on the industrial network and on the intranet. I have to expose those services. I can't duplicate them. So there we are. The data needs to go from one network to the other. We can use data diodes, but data diodes as a diode are just unidirectional, and sometimes you would like to also have going data in the other direction. And then, of course, there's the internet. Shit. Forgot about that one. But we need to expose certain services. If you run a conference, the virtual machines with your conference management system needs to be visible to the internet. All your web pages need to be visible to the internet. So, just hoping that our firewall is making it clear and blocking all the malicious stuff, or not. Unfortunately not. Here are two examples of accelerators, one in Berlin, BESI 2, and the ALMA Observatory in the Atacama Desert in Chile, which got ransomware. Because, got a connection to the internet, this is what's happening, and if you don't have good defenses, it will happen to us. So for me, it's not a question of the if, it's a question of when, and I'm just trying to bridge the time. If it's happening, I'm not working as CISO at CERN anymore, but I'm being a gardener or whatever else. But at the moment, I'm just trying to survive. And we haven't done anything yet. We just cabled our network. Because next thing is administrators. Who of you are administrators in one way or the other? Look here, administrators. Think of that one. I give you a console on your desk because you have to administer the hardware. Good. I give you another console over here because you have to do the provisioning. The first thing you tell me is, what the fuck? You would like to have one. So you're getting one, and what I'm doing, I'm bridging networks. Again, because it's for convenience, mantra number 3 rules the world. And then, of course, your administrators, you do not want to sit here and then having SourceForge and your internet here. You would like to put everything together, so I'm bridging our network, because also you would like to be able to work from home and see the status of your computer center while sitting somewhere in Hawaii Beach. Because you are agile and flexible, as I'm putting it on the slide. Maybe multi-factor is saving us because at least I need to steal your hardware device from you. Question mark. You heard presentations about this one, and even there were fuck-ups in the past. So last pass said employee's home computer has hacked. So if you're an administrator, I go for your home computer, and my computer center is at peril because I do not know how to set up my network properly. And then we're coming to provisioning. I would like to provision. So somehow, first I have to monitor. So let's do monitoring. Monitoring means I would like to see all my single virtual machines. Are they up and running? How much CPU they're consuming? How much memory they're consuming? How much storage they're consuming? What about the network bandwidth? How many users there are? And so on. But I also would like to ping all the devices. Are they still up and running? Is my hardware running, or do I need to move hardware? So I'm bridging networks once more because the ping from my provision network needs to make it into the management network. And we didn't speak about provisioning. So here we now provision the computer center. Puppet, Chef, Ansible. Docker, Kubernetes, those are the services which you need to provision your virtual machines and your containers into your computer center. Okay, I connect them to the provision network. And I connect to the provision network also databases and storage systems, because somewhere your containers and your virtual machines need to be stored. So I put all this infrastructure again on a provisioning network, which is more or less fine, it's just one network. But do I understand all the dependencies? Did I get everything together to start up my computer center? What about if I have to go for business continuity and one of the databases is going down? I need to have a database somewhere else in the same computer center, or producing problems? What about disaster recovery? My computer center is burning down. Do I have everything in place to restart the same computer center somewhere else on an empty field? Actually, we're running 2 computer centers, which is something like 3 kilometers apart, exactly for this purpose. And Puppet and Ansible, and my databases, and my storage systems. I do not want to have them in a separate computer center. Those are running exactly on the same infrastructure, which is depicted here on your left-hand side. So they are running self-hosted in the same computer center. So somewhere here, On the hypervisor, in the VMs and containers, you find somewhere the single sign-on and the LDAP, and you find the Active Directory there, and you find Puppet, and you find Ansible there, and the database and the storage system. So did I get everything together? Put everything together, so now it's self-hosted on the same bare metal, on the same virtual machines, and it's same containers, but now I'm running the problem. If I've shut down my computer center is going down, loss of power, we get 10 minutes autonomy on the computer center. After 10 minutes, we can either toggle to diesel. If the diesel is not kicking in, then we have to shut down parts of the computer center because the UPSs do not provide the 3 megawatts of power for the computer center for longer. So shutting down is easy. Lights going off. But now if you want to ramp it up again, what do you ramp up first? You ramp up first your network, of course, but then you need to ramp up all your virtual machines, which need to have single sign-on. But the single sign-ons are running on the virtual machines, which are not up yet. So what about the Active Directory? Forget about the single sign-on, but the Active Directory needs to come up first. But the Active Directory is running on the same hardware, which is not up yet, because to start it up, I need to have the provisioning system running and the network. So you have to think this really properly through to know what do you start up from the very beginning. And sometimes you can have nice surprises. You get nice loops there where it is not starting up because you have interdependencies. So we're studying interdependencies, and I can tell you I'm already starting tossing and turning in bed because this is preparing nightmares to me. And then forget about this one, I put everything into the DMZ. It's a big DMZ, but at least everything is there contained, separate blob of networks. But the next problem I have is single sign-on, Puppet, Ansible, storage systems, databases. My user community, all these 15,000 physicists, they would like to use the same infrastructure for their own purposes. They would like to use Puppet to spawn up their own little computer center in our computer center. So having a cluster of 100, 200, 1,000 virtual machines doing data analysis, provisioned by Puppet, coming with containers out of the databases, out of the storage system. So I have to give them some access, which means everything into a DMZ and connected to the internet and not to my provisioning network anymore. Sweating in my bed. And then here's where the real nightmare is starting. Who got that idea? Cloud computing. Why, oh, why do we have cloud computing? I understand that because of mantra number 3. I need to connect my computer center now with Amazon, with Azure, with Google, with Oracle. Oracle is saying, no, why don't you have our databases, which we have at the moment on-prem, not in their cloud? Good idea. What about the single sign-on, which you're running at the moment with open source tools on site? Why not moving it to Azure ID? And so on. Because I have no clue how to funnel an external computer center properly with mine. Have you ever done this, connected your local computer center to Microsoft Cloud? Have you ever figured out how many IP addresses you have to open up to get it properly running? It is not like, 5 for load balancer and Exchange Online, and maybe 5 for Teams and whatever else. You're opening Class B networks, all of them of Microsoft, of the country, of the data center you're in your tenant, in Amsterdam or in Switzerland, wherever. Maybe even 2 because you would like the redundancy of computer centers, so you're not bound to 1 computer center, you have at least 2. You're opening Class B networks, and I don't know, and Microsoft cannot tell me what's also running into their Class B network, not belonging to CERN, but maybe to somebody who is not as friendly as we are. Stolen Microsoft key may have opened up a lot of more than US government email inboxes. Sure it did, I'm pretty sure. ServiceNow, and this is just coming from 4 days ago, we're using ServiceNow, which is a cloud service hosted outside CERN, but interacting with our processes because it's a ticketing system, ITIL compliant. They got compromised. Still not completely clear what happened there, but I think we have been spared. And then most recently, Okta again. This is 4 days ago, October 20th. Hacker stole access token from Okta support unit. That is the same Okta which lost 10,000 logins, 2 years ago, 3 years ago? Cloud computing, brilliant, let's move in the cloud. Mantra free, let's save money. Good. Having done that, and then we got programmers. Physicists are de facto programmers. I like them. They're doing programming for control systems. That's the business. They're doing analysis jobs. They're programming their machine learning model and so on. They're programming web pages. And of course, if you program, you reuse what's already there. So I'm talking about virtual machines. But do you have your own virtual machines? No, you don't. You get your virtual machine somewhere from the internet. Yeah, from Red Hat or, don't know, Docker.io, some containers. So they get their containers. They download the containers in the computer center, and they run them up. Or doing programming. Everybody who used programming but me, because I suck at that one. But you do. And you're using NPM, do you? NPM, PyPy, pulling in libraries automatically from wherever they're coming into your software stack, and then you have your common integration pipeline, you build your code, and then you push it into your production without knowing what you're getting in there. So how do you secure import of external sources, containers, virtual machines? SBOM, software bill of materials maybe, but I'm struggling, and this is happening. Supply chain attacks via software, and via more software which is malicious, compromised, and so on. And I'm struggling with this one. So this is normally where I'm waking up, because you've seen we started with something very simple, toasters. 3 layers. And then somebody invented hypervisors. Where's the difference to CH root, by the way? But anyhow, I'm not complaining there. My drawing got very complex, convoluted, and complicated. It's a little bit like this software stack here, where something in your software stack is a library which is maintained by somebody in Nebraska who doesn't even care anymore, maybe. So if I now look at the risks, how do I mitigate the risks? And this is why I'm looking for input, and maybe for the questions afterwards. I'm really interested in, what do I do? I'm running hardware which is bridging networks where I cannot separate anymore because everything is running on the same hypervisors. If the hypervisors are getting screwed up, I'm losing all the virtual machines which are running on the hypervisor, not to talk about the network infrastructure. I have to bridge networks because of basic services. We talk about single sign-on. That is a very, very nice concept. But if I have single sign-on, well, to have single sign-on on the accelerator network, and the same accounts for accessing your mailbox in the cloud, and the same accounts for going on your conference management system on the intranet. So I have to bridge networks. NTP, yes, I can put up 4 antennas on the roofs. That doesn't cost anything. But DNS, I have to bridge networks. Databases are bridging networks. If I talk to my database teams and say, look here, yes, you maintain Oracle here, and you maintain Oracle over there, they say, God, no, we like to have same provisioning because of mantra number 3. It's much more convenient, it's much more cheaper. And we're being much, much more agile. Which also means that we're creating lots of cacophony of dependencies. Some inherent loops of starting up the computer center, inherent loops of running the services. It's called agile, elastic, but it's heterogeneous. And I'm really struggling how to see that security can fold in there. Everybody's saying, look here, that's a huge benefit. I need to do a machine learning analysis. I need to have another 100 virtual machines. There we're going. Just spawn them up and you can do it. But if your hardware is restricted and you cannot do it because you just have a limited set of hypervisors, your elasticity is gone. Yes, the benefits of cloud services are definitely, we're there to somebody, not me. But we have to connect to cloud services because my IT management, for example, wants to have us more on the cloud, and I have to see how I secure the cloud. Somebody in the cloud with Microsoft Exchange? Nope. Here you are. Dequarantine emails, ever done this? One user request for dequarantine an email, 12 clicks. 12 clicks for one email. I got 20,000 people. Scale that up. I got a really muscular finger here. And then we're talking about external software dependencies. I don't know how you do programming, but at the moment I'm struggling with this one because that's the nicety of software. The beauty of software is we can reuse software. Open source software is everywhere on the internet. You just download it, but it's like ordering the pizza of your favorite restaurant, and then the chef is changing, and instead of getting your delicious pizza Hawaii, you're getting a pizza full of salmonella because you just called the same number, but chef changed. And I'm wondering what the solution is. So I said I'm waking up, and I'm really waking up because KISS is gone. There is no keep it stupid, simple stupid anymore. It's now called AC/DC. All convenient and damn cheap. And this is what's more or less happening. This is where zero trust comes in as the new mantra. I always thought this is something like a buzzword of some marketing guys, but now more and more I'm thinking about my talk here, I'm getting an idea what zero trust really means. I cannot trust any component in my computer center anymore, and I have to secure them. How would you do? Defense in depth, of course, but defense in depth is costly, and defense in depth already is violating against mantra number 3 and AC/DC. So here I am completely struggling, having nightmares. I don't know how to secure this bunch of computer center there. And if I'm talking to the Netflixes and others on the world, they will not really tell me. But anyhow, they have an IT team which is much bigger than everybody here in the room, and maybe they can cope. I can't. So I'm looking forward for your input, either now or maybe later around the coffee. Thank you very much. Look at the timing.
Yeah, perfect timing. There was a bit of a rant, Stefan, but I got what I deserved. Wonderful. We have time for one answer from the audience. I thought that was easier.
Questions?
Okay. How long do you cope with that, Stefan? The problem?
Defense in depth.
Defense in depth.
Yeah, to me, it's puzzle layer, puzzle layer, puzzle layer, just putting puzzles in place.
And then keep praying.
So what I didn't mention here, yes, we're starting up with SBOM. We have a brilliant SOC and intrusion detection systems. We're doing central patching where we can. We're monitoring code, so everything is going through a GitLab instance on site, where we're running the SAS tools and DAS tools on top of that to analyze what shitty programs the physicists are putting inside. So we're now looking into, can we do curation on containers and virtual machines? So there are tools like Harbor, which telling you, here's your virtual machine. It has this list of vulnerabilities. Moment I'm struggling because I can't tell an end user, here's your list of vulnerabilities, because the end user will say, yeah, and what can I do? He cannot fix it, but he needs to have the functionality. I can tell him, yeah, use another virtual machine, which is better, this one here, but no, this has Python 3, I need Python 2.7. So we got different layers in place there. Not joking, it's like this. So if you're running in a very, very big infrastructure, you got legacy code, lots and lots of legacy code there, which you just can get rid of like this. So we're putting in security measures bit by bit all over the place to hope that there are no too big holes to go down the whole.
Yeah, it's like this Emmental security where you stack a lot of cheese behind each other and hope nice. No hole punches through.
Let's have a fondue tonight.
Let's have a fondue. Brilliant. We do a fondue for the 10th anniversary tonight. Good. Wonderful. Thank you very much, Stefan.
Thank you very much.
A bit of chocolate for you.
Thank you.
See you around.